Okay, so today we're talking about identity matrix and also the inverse matrix, and we need to know about the determinant because that helps us find the inverse. So we're going to learn manual ways, so it means you have to calculate it yourself, and we're only going to do that with a 2x2 only manually. The rest we'll do on our calculators, and I'll show you both. So first of all, we're going to look at an identity matrix. So you need to take note. So an identity matrix is a square matrix, and what do we mean by square?
Same number of rows equal.
Yeah, rows and columns are the same. So for an example, you could have a 2x2, 3x3. That's a square matrix. The rows are the same as the columns. Okay, so it's a square matrix, the identity, and you also see that you have ones on the leading diagonal. Can you see that? And all the rest are zeros. Okay, now an identity matrix, it sort of acts like a number one. A number one would do. So, and what I mean by that, if you times 3 by 1, you get 3, don't you? Can you see that when you times something by 1, you get the same thing? Yes? So if you have a matrix and you times it by the identity matrix, so the identity matrix is often given with a capital I. If you times a matrix by an identity matrix, you'll get the same matrix back. Does that make sense? Yeah? So it acts sort of like a number one. So if you just remember that about an identity matrix. So now we're going to go on and look at the inverse matrix. So the inverse of matrices. So what I want you to remember, if you have x, the inverse of x is actually equal to, you can either call it 1 over x, or it could be like that, x to the power of -1. And that means the same thing. So can you see that if I times a number, say I go 3 and I times it by its inverse, so its inverse would be 1 over 3. Can you see that ends up with 3 over 3, which equals 1. So if you times anything by your inverse, you get 1. So also, when you times by an inverse, it's sort of like dividing, isn't it? Because you're dividing by that number. So if you times something like, if you say you're going to times by a matrix inverse, so that would be the inverse of A, it's like you're dividing by matrix A. That will help you with doing problems if you can understand that concept. If you're timesing by the inverse, it's like you're dividing, because we don't really have dividing in matrices. We only times by the inverse if we want to do that. All right, so we're going to work out how to manually find the inverse of only a 2x2. So you can see here we have a 2x2. And first of all, we need to work out the determinant of this matrix. Now, the determinant can be found by, so we'll often refer to it as det A. Now we're calling it A because this matrix is called A. Now, can you see what I'm going to do is I'm going to multiply whatever number's there with D. So you can see A times D. Then I'm going to minus the B times C value. And so here you can see we've got the formula for determinant. So if I go over here and do these examples, so if I said find the determinant of H here, so det H, now it's going to equal this spot times this spot, so 2 times 3 minus the 4 times 2. Can you see what that means? That it's the position those numbers are. So then you do that, that would be 6 minus 8, so equals -2. So I would just say the determinant of H equals -2. If they ask me that simple question, That's what you do. If I go to find the determinant of this one, A, so what do you think it'll be? It's this spot times, yeah, so 2 times 5 minus 3 times 3. So we get 10 minus 9, so this one's determinant 1. If you're trying to do it in your calculator, because this is just a 2 by 2, you won't know how to find the determinant of a bigger one. Now, you can only find the determinant of a square matrix, but you won't be able to find the determinant of that because I haven't shown you. You only know the rule for 2 by 2. So if you want to do a bigger one on the calculator, you'll do this. You type the letters DET and then you open the bracket, a curved bracket, then you pop your matrix and then press enter. Now, can you see I put in this matrix here and I showed you. I'm going to pause it for a minute and show you on the calculator. Okay, so now we're going to look at how to find the inverse matrix. So the inverse matrix, which can be written like that, or you might see it written like this, more likely. So the inverse matrix, once again, like I said before, that's used, it's like dividing, and so we need to learn how to do it. Now, you only have to learn how to do a manual one for a 2 by 2, okay? So I'm going to show you how to manually do one for a 2 by 2. Then I'll show you on the calculator how we would do anything bigger. All right, I'm recording. So you only ever have to manually do an inverse for a 2 by 2. So let's have a look at it. So once again, we've got a matrix and they're just showing you the positions with A, B, C, and D like that, yeah? So the inverse matrix, the formula for inverse is, you can see what you have to do is you go 1 over AD minus BC. Now, can you see that before? That's our formula for the determinant, wasn't it? That's what we did. So you can see the inverse uses the determinant there. And then what you have to do, can you see that A and D have been swapped around in positions there? And you can see B's been made negative and C's been made negative. So that's what you've got to do. So if I was just going to do this one over here in steps, all right, let's work it out. It would be, if we're doing inverse A, it would be 1 over 2 times 3 minus 4 times 2. There's the determinant. And it's going to be outside. I'm going to flip these two, change them around. And I'm going to make these ones negative. So that's what you've got to do. Now, when you end up doing that, you'll end up with this being a number. So I'll have 6 minus 8. So I've actually got negative 2 outside the matrix like that. All right. Now, when you have a number outside, that's like a scalar multiplication. So you will, remember what we do? We just times everything by the half. So if you look at that, I would have 3 over negative 2, negative 4 over negative 2, negative 2 over negative 2. This is me timesing everything out by a half, negative a half. Now, can I simplify? You might see that simplified and you'll see, I can't simplify that one, but you'll see that's 2, that's negative 1, and that's negative, oh sorry, that's positive 1, and that's negative 1. All right, so I just found the inverse manually for that one there. All right, so now going back, you can find the inverse, and now that's provided that the determinant's not equal 0. If the determinant equals 0, you cannot find the inverse. The inverse is not defined, and this is very important that you're seeing this. That means that the matrix is singular. So maybe underneath the word singular, just write det equals 0. Can you have 1 divided by 0? Have you ever tried that on your calculator? If you try to do 1 over 0 on your calculator, you'll get undefined. So can you see up here in the formula, I would have, if det equals 0, I'd have 1 over 0, wouldn't I? And you can't do that. So then, therefore, it can't be solved. You can't find an inverse for that one. So you need to just remember, if the determinant equals 0, you can't get an inverse, and they will call that matrix singular. So if it's the det equals 0, you'll call it singular. Now what you're going to notice, if I times a matrix, so if you times a matrix by its inverse, so you do this to the -1, you're going to find you get the identity matrix, which was like ones, wasn't it? Yeah? Ones down the zeros. So you need to remember that. If you times something by its inverse, you'll get 1. And we talked about that when we timed 3 by its inverse, we got 1. Okay, so here's just a note to say we use our calculator for anything bigger than a 2 by 2. I'm just showing you, so you guys might want to put a little note in there that we use the power key and the -1 for the calculator. But I'm going to show you how, if you times it by its inverse, you get -1. Wait a minute. Okay, calculate the determinant of the following matrices and state whether those are singular matrices. So if it's singular, what does it have to be? Yeah, det needs to equal 0. All right, so we're going to go and calculate the determinant. So the determinant of this one will be, what will it be? 5 times 2, good, minus 3 times 2. So we get 10 minus 6 equals 4. And it's not singular, is it? Yeah, so not singular. Okay, let's do this one. The determinant, what will it be? It'll be 0 times 3 minus, which would be 0 minus 0, which is 0. So this one is singular. Okay, really easy. You couldn't, so there's no inverse for this one, is there? No inverse for this one. Inverse can be found for this one. Okay? Just so you know. There'll be a whole heap of other questions that you've got to do. So then the next part, you got this next question. It'll say, show that the following pairs of matrices are the inverse. So what you need to do is you have to find the inverse of A and see if it equals this. So let's go and manually do it. So inverse of A equals, it'd be 1 over the det, and then you'll remember you swap those spots and you make those ones negative. All right, so let's go and do that. So what would the determinant of A be? It'll be 3 times 2 minus 1, yeah, or 1 times 5, yep. So you got 6 minus 5, which is 1. Okay, so you're going to have 1 over 1. Then you flick these two spots, these two spots around. So you've got 2 and 3, and these ones become negative. None. All right, if you times everything out by 1, you just get itself, wouldn't it? Yeah. And is that B? This is B, isn't it? Yeah. Yep, so we just proved that that's the inverse of that one. Yeah? So that's what you need to do. You have to show you're working out.
B's the inverse of A.
Yeah, B's the inverse A. So B equals inverse A, yeah? All right, you just have to prove it, so it's mainly just practicing. Okay, and then the last one that you've got to do is find the inverse of each of the following matrices and check your answer by multiplying each matrix by its inverse. So let's do that. These will be a little bit more bigger. So first we need the determinant. So what will that be? It'll be 1 times 9 minus 4 times 2. So what's that? 9 minus 8, which is 1. Okay, let's go find inverse A now, which will be 1 over the det, which we said was 1. What number will go up here? 9, good. What will happen to the 4? It'll become negative, and this will be negative, and this one became 1. So if I multiply the 1 out, so I end up with this. So this is inverse A. So the second part, what they want me to do is they want me to multiply A with its inverse and see if I get check your answer by multiplying. What should I get when I multiply those two together? I should get the identity. I should get ones. So let's practice our manual multiplication, because that's probably one of the harder bits I said. So I've got 1, 4, 2, 9. I'm going to multiply it by 9, -4, -2, 1. Okay, this is a 2 by 2. This is a 2 by 2. Can I multiply them together? Yep, this is equal, isn't it? And what will my answer be? It'll be a 2 by 2, won't it? So I'm going to just put it out like this. So I'll have 2 answers, like 2 rows and 2 columns. So let's do it. We would go first row, first column. So it'll be 1 times 9 plus 4 times -2. Good. Next one, it'll be row 1, column 2. That will go here. So 1 times -4 plus 4 times 1. Let's do the next one. It'll be row 1, column 1. So that one will be 2 times 9 plus 9 times -2. Yeah. And one last one. It'll be row 2, column 2, which will be 2 times -4 plus 9 times 1. Tidy all that up. You'd have 9 plus -8, which would be 1. Then you'd have here -4 plus 4, 0. Then you've got 18 plus -18, because that's a minus, 0. Then you've got -8 plus 9. Is that the identity?
Yeah.
And that's good. So you've proved that that is the inverse. Okay?